And next step is similar to the previous one which we saw. We attach the policies, right? We create a policy, we attach the policy, and the policy here is give full access to S3. So we trusted account B, and then we have attached a policy which is giving full access to S3 bucket, and this is how it looks like. And if you see the trust relationship, right, in the second screenshot and the first screenshot talks about the permission policy, what you are granting. The second screenshot talks about whom do you trust, right? So here in this policy, I am trusting this account number, the account P1547, which is starting from, right? I trust this. And then the trust relationship will look like this, right? The trust relationship in the JSON format will look like this, right? If you see here, the action is STS assume role. So STS is nothing but a service, secure token service, right? That we saw. So this particular service is, this particular action is allowed from this account. So what this means is the account B, which is trusted, can request account A and then generate temporary credentials by using STS assume role. So STS assume role will help you to generate credentials or the tokens that is required for accessing the resources. So here I'm trusting the account B to do an assume role, right? Call. So account B, right? So this is which we created the account A, and now in account B. So account A, as an admin, I have trusted the account B and I've created a role, everything. And please make a note of the account role here. So in the second screenshot, there is something known as role ARN. This is a must. You need to copy this or somewhere make a note of this, because this will be helpful when we go to account B. So now we are into account B. So the person in account B wants to access the resource in the account A, right? So in account B, what we do is, that is DevSecOps account, we create a policy, right? We create a simple policy. And this policy, if you see in the first screenshot, will look like this. So here we have effect allow. Action is STS assume role. So we are leveraging this assume role API call, and resource. Resource is the role ARN. So as I mentioned, the previous slide and the second screenshot, we need to make a copy of this role that is created in account A, right? So the admin of the account A will create the role and will share the particular role ARN to account B administrator. Now the account B administrator, what he'll do is he'll use that ARN, the role ARN, and will write a policy to trust, right? So once he has this role created, he can attach it to any entities, IAM entities. He can attach it to the account B admin, can attach this STS assume policy to a user, a group, or any EC2 instance or any service, right? So this is how it works, right? So similarly, here, one of the EC2 instances, right? This is an account B. So our policy, the scenario 2 is written in such a way that there are some S3 buckets in account A, and those buckets need to be accessed in account B. So here in account B, say I want to access those buckets via EC2 instances. So what I do is I spin up a EC2 instance and I attach this particular role that was created. Previously, we created a role, right? The account B admin. So he will attach that particular role. If you see cross account role. So this particular role is something role and named it as cross account role. So this is attached to the instance. And once it is attached from EC2 instance, you can start executing commands and then run. So here, if you see, I don't need to configure any credentials, nothing. All I have to do is start using by running either commands or leveraging AWS SDK within the EC2 instance, which has this role attached, and start consuming S3 resources. So, right. So this is how it is done. So STS, on a high level summary, STS is basically provides temporary security credentials, which can be configured to live either a short term or a long term, right? It can last long from certain minutes to several hours, right? And there is no need for what you can say hard coding any credentials. So this is basically like a temporary security credentials. As long as the particular role that we created, the cross account role which we created, is attached to the EC2 instance, as long as it is attached, the particular EC2 instance can access the S3 bucket contents that are there in the other account. Right. So here we can configure, say, 15 minutes for an STS credentials to last long, and once that 15 minutes get over, right, the security credentials, the temporary credentials will expire and you no longer will be able to access. In that case, all we do is we leverage an API call known as STS assume API call within the CLI command, and highlight the role, right? Highlight the role for which we are requesting the STS. So this will give us a new set of credentials, and then we can start leveraging the same set of credentials to continue accessing S3 bucket contents in the EC2 instance, right? So what are the advantages of consuming this IAM role and the STS service, right? Thing is, from the security perspective, hard coding of credentials is avoided, right? And the temporary security credentials can be limited to a particular set of time, right? And you can revoke them as well. We can revoke. So tomorrow, if say that role is that EC2 instance doesn't need access to that S3 bucket in the other account, you can basically remove that role from that particular EC2 instance. That is how it is easier. So how does it work in the backend, right? I spoke about STS assume role, and there is basically a STS call that will happen and a temporary credentials will be generated. How does this happen? So this is how it is, right? So I've logged into that EC2 instance where I've attached that cross account role. I am into that machine, EC2 instance machine, and I execute this command, AWS STS assume role followed by the role ARN. As I told, this particular role ARN is created by the account EA, right? Account admin, and he shares with us. So you enter that role ARN and you give some, this is something that is customizable. You can give any session, right? I've just given it as a test here. And right, once you enter this, you'll see the credentials. These are temporary credentials. So if you see, there are access key ID, secret access key, and session token generated for this user, and start leveraging it. Right. So we see, okay, there is a temporary credentials are generated, but it has to be stored somewhere, right? Without caching of credentials, they won't be able to access these AWS resources, right? Where are these particular credentials stored? So that is where I told initially about 169.254, 169.254, right? So basically this particular instance is private to your VPC, right? Private to your VPC, and none of the outside of the EC2 instance cannot be accessible. So only the machine, right, where you generate the keys will be only able to read the metadata. So the metadata will contain a lot of information, like what are the security groups attached, what are the EBS volume, space, all those things. On top of it, it will also store security credentials here. And if someone wants to access the security credential using this IP address, it's not possible. Only it is possible if the user is within the EC2 instance or in that machine. And this is a reserved IP address. So need to make a note of this. This is a reserved IP address and cannot be accessed outside the EC2 instance, right? Say there are two EC2 instances in my AWS, right, within the same account. So the metadata of one EC2 instance cannot be accessed by another instance, right? Only the particular self EC2 instance can access, right? So this is about IAM role. We'll quickly jump to the inline policy. So inline policy is very similar to AWS managed customer policies, very much similar, but only difference is so far whatever we have seen is something that can be applied to n number of users. So when it comes to AWS managed policy and customer managed policy, once it is created, right, you create a policy, say you name it as A, right? And that policy can be applied to any entities. It can be applied to 10 users. It can be applied to 10 EC2 instances within the account. So this can be done. But when it comes to inline policy, this is targeted to a specific user or a group, right? Or a particular role. So you write a policy in a similar fashion, JSON document with a set of instructions, and you attach it. It's a one-on-one relation, and that is the biggest difference here. And the other key difference here is once you delete a particular IAM identity, IAM. So say today I've created an inline policy and attached it to an IAM user, right? And tomorrow, if I delete that IAM user, right, the policies that are the inline policies that are attached to the user will also be deleted, right? Just make a note of this. Only this is applicable for inline policies. If it is AWS managed or a customer managed, it will not be, right? Even if I delete user, that particular policies will be there because that is there for consuming for a one-to-many relationship, right? Whereas inline policy is specific to one-on-one policies, right? So the inline policy attached to that user will also be deleted, right? So what are the use cases which we see, right, for inline policies? Say in a IAM group, right, when a particular user or a principal requires more access to AWS resources. So for example, say in IT, right, we'll assume IT group. In IT group, there are, say, 10 users, right? Out of 10 users, um, I need one of the user within that IT group to have access to another S3 bucket, right? Which is not accessible within the group, right? I want only one user in the group to have access permission, right? So in that case, I can leverage inline policies. So basically what I'll do is there are common policies common policy that is attached to the group. On top of it, one of the group member, right? One of the member in the group wants to access additional resources. So I can write a separate policy specific to that user and attach it to it. So only the user in the group can access, and I'm not exposing that policy to any other members within the same group, right? So that is the biggest use case I've seen in my experience when it comes to inline policies. So let's jump to the final section, IAM and its security, right? So these are basic security concerns which anyone can take care of. So all we understand in IAM is there is something known as passwords being generated for web console access, user keys, access keys generated for programmatic access, right? Make sure all those keys are managed securely, right? So first one is lock your AWS account root user access keys, right? Usually what we recommend is once a AWS account is created, right, that account is known as a root account, right? We basically not recommend generating programmatic keys for that root account. The way we ask the users to consume any company, if you go to any company, right, from Google to a startup company or any company, right, the way they work is you create a root account, and then within the root account, you create IAM users, IAM groups, and then you use users and groups to manage these services, right? We will not consume root account itself, a root account alone, right? Root account is specifically for billing purposes. When it comes to AWS billing and other things like AWS organizations, other concepts, for managing the account, we consume root account, right? And for working perspective, programmatic or consuming any resources, we leverage IAM accounts, right? You create users and start using it. As a user, you log into the AWS and start consuming it. Second is create individual IAM users. That's what, as I mentioned, you create IAM users and then grant least privilege as much as possible, right? Say if a particular user or a EC2 machine needs access to S3, right? It doesn't mean you have to give full access to the S3. Understand what are the requirements. Say if the user needs access to a specific bucket, got it. If it is a specific bucket, give access to only those specific bucket, right? Rather than exposing all the buckets. So make sure the least privilege concept is followed across the IAM policy while you write the IAM policies. Then in IAM password, right? When we generate passwords for web console access, AWS web console access, make sure you follow the screen. So in the screenshot, you can see the password policy. Make sure you have minimum password length followed and the combination of password contents, right? It should have one uppercase, lowercase, numbers, and special characters. You also have password expiration and history enabled, right? So when you enable password expiration, it means you every 90 days or 180 days, the user needs to reset his credentials, right? Change his credentials. And also if you enable password history, it basically means our user cannot reuse the same password which he configured previously, right? So those kind of security things have to be taken care. And for root accounts, right? Root accounts and admin accounts, make sure you have MFA enabled, multi-factor authentication, right? So this can also be done. If you enable MFA, even if the credentials are compromised somehow, right? The AWS credentials are compromised, MFA will save you from account takeover issues, right? And MFA is supported. You can leverage any Google Authenticator or Okta Authenticator, any authenticator, right? You can configure. This is one of the key rotation of access keys, right? From a programmatic perspective or programmer perspective, when you consume the access keys, make sure you rotate it, right? If I'm consuming long permanent keys, make sure you rotate it every 180 days, right? Ideally 180 days. And also monitor the policies, right? The last point, monitor whatever the roles and policies that you have granted on to which principle, right? I don't want to grant policies or roles to someone who's outside, right? Or some other account who doesn't even need that access, right? So make sure you go through policies, but going through policies roles manually is a cumbersome process. It's something very hard to manage, especially if it's a large company, like say 1,000 users plus, right? It is hard. It's literally impossible to manage those. So to manage those, there is something known as IAM Access Analyzer service. So this is a native service to AWS. So what we do here is basically the objective of the service is once you enable the service, it will monitor within your account, right? Within your AWS account, it will monitor all the policies, roles, users, everything, right? It will monitor and see if if there are any policies that are granted to another account, right? So if you see in the screenshot, right, it has highlighted two findings. So we have just run an IAM Access Analyzer, and this tool has highlighted saying there is a bucket name known as block.3vikram.tk, and it is exposed to all the principals, right? So in my account, all users can access this particular S3 bucket. So it highlights this and says just revisit this and make changes accordingly. And similarly, in the second finding, it says it's a cross account rule. So it also says there is an other account, outside account, which starts from 1547 that has access to S3 service in your account, right? So review this and take actions necessarily, right? So from the automation perspective, what we can do is we can enable this access analyzer and yeah, this is the way to do it. So if any of you guys have a bit of understanding of the CloudWatch event, there is something known as CloudWatch service. So within the CloudWatch service, we can leverage something known as event rule concept, or we can even leverage event bridge. So using this, what we configure is, if you see the service name, I'm leveraging an event pattern. So the service name is Access Analyzer. The event type is Access Analyzer findings. So what this means is any findings that that Access Analyzer reports, right? I want to do something on this. So if there is a finding, I want to, so here in this case, I've created an SNS topic. So SNS service in AWS helps you to alert or notify you, right? Notify to your email address. So I have configured my personal account, personal email address in the SNS topic and set it as a target. So the target can be SNS topic, or it can be even any Lambda functions running, right? So here in this case, I've pointed out SNS topic and then saved it. So what this basically does is whenever there is a access permission granted, access permissions in the sense cross account, outside my account, some resources are granted, or within my account, all the users are granted, right? In that case, I'll get a notification to my email address saying so and so permissions are being exposed, and basically for us to review and see if it is necessary or not to be given. So so we can leverage IAM Access Analyzer as a security tool to monitor against excessive permissions if granted, right? So that's all from the IAM security side.